Okay, everyone, we are going to look at our year-end review number 5, and we're going to look at the unit of proportional reasoning. So we did a couple different things in this unit. We started talking about best buys, and we looked at unit rates and proportions, and then we moved into the concept of scale factor. So we're just going to go through and review those main concepts, and again, hopefully this refreshes your mind. So rates are often used in best buy situations. So for example here, 3 kilograms of ground beef cost $8.27 at store A, and 1.9 pounds of ground beef cost $2.96 at store B. Who has the better buy? So when we're doing better buys, you have to make sure that you're always comparing apples to apples. So in this case, we just want to make sure that the units match. Now it doesn't matter if you keep dollars and kilograms and put them both into that version, or if you put both into dollars and pounds. It really doesn't matter. So I've given you the conversion here that 1 kilogram is 2.2 pounds. So what I'm going to do is I'm just going to make this 3 kilograms. Okay, so if 1 kilogram equals 2.2 pounds, and I have 3 kilograms, then that must mean then that I have 6.6 pounds. So essentially at store A, I have $8.27 for 6.6 pounds. Now it's very important that you put your units in here. So if I go $8.27 for 6.6 pounds. Now if I divide those two numbers, so if I go 8.27 divided by 6.6, so I'm just going to punch that in. I get out 1.25. So what that represents $1.25 for 1 pound. So that's my unit rate. Now I also have 1.9 pounds of ground beef cost $2.96. So again, so on my first one, I did the dollars on top and the pounds on the bottom. So I want to make sure I do the same thing on this one. So $2.96 for 1.9 pounds. So that is $1.56 for 1 pound. So store A is $1.25 for 1 pound. Store B is $1.56 for 1 pound. So which is the better buy? That would be store A. Okay? So make sure that you write your units in so you always know what you're comparing. So rates can also be shown graphically. So how fast was he driving from point A to point B? So if we think in terms of speed, okay, so fast is typically kilometers per hour. Now per just means divide. So I've got my kilometers right here. So at point B I was 220 kilometers, and point A I was at 55. So I need to figure out how far this is. So I'm just going to subtract those two numbers. So if I go 220 minus 55, I get out 165 kilometers. And he covered that in, so from 0.5 hours to 1.3 hours. So how far is that? So again, if I subtract that, I get out 0.8 hours. So he did 165 kilometers in 0.8 hours. So again, if I divide those two, so 165 divided by 0.8, I get out 206.3. So 206 kilometers per hour. So in other words, this person is going insanely fast. Okay, so we're not going to worry about the meters per second. Okay, we will just leave that off. Okay, so the next major concept we looked at was scale factor. So a scale factor of 1:3, the way we say that is we say it as 1 to 3. So a scale factor of 1 to 3 means a reduction. And the reason why it means a reduction is if we take our colon here and write it like a divide sign, it means 1/3. Okay, so in other words, everything has been reduced by 1/3. Okay, so another way to, so this is how we write it as a fraction. We can also write it as a decimal. So if you go 1 divided by 3 on your calculator, you get 0.3 repeating. And we can also write it as a percent. So to go from a decimal to a percent, we times by 100. Okay, so in other words, if something's been reduced by 33%, that means that it's 1/3 the size of the original. If you have a scale factor of 4 to 1, so again, think of that as 4 divided by 1, so that would be the fraction, or you could just write the number 4. As a decimal, you would either write 4 or 4.0. And again, to take it into a percent, we always times by 100, so that would be 400%. And that's an enlargement, okay? So it's been increased by 400%. So scale factors can be shown as ratios, so something to something, decimals, fractions, or percents. Now, typically when we do all of our calculations, with scale factor, we always want it written as a decimal or as a fraction. So if you have it as a percent or a ratio, you have to first convert it into one of those forms. So we have our basic formulas. So the first formula is original times scale factor equals new. Now, how you know if you're going to use this formula, you need to look at the units. So if you're going, say, from centimeters to centimeters, okay? You also may see one of these words. It may refer to it as linear scale factor, or it may be referred to as perimeter scale factor. Either one of those, though, means original times scale factor gives you new. The next one we had was original times scale factor squared gives you new. Now again, if you look at the units will be squareds to squareds. So if the units are squareds and squareds, then the scale factor also has to be squared. Everything has to match. So the key words that you'll see in the questions, they will say original area or original surface area, or I'll talk about the area scale factor or the surface area scale factor. Original times scale factor cubed equals new. This one is when we go from centimeters cubed to centimeters cubed. Again, everything has to match. And the words you'll see in the question are volume, or you'll sometimes see the word capacity. Now, when we use the word capacity, typically you'll see the units will be liters or milliliters. Because liters and milliliters is just how much liquid something can hold, and how much something can hold is how we define volume. Okay, so the last thing is enlargements and reductions. So if we're doing an enlargement, your scale factor needs to be a number bigger than 1 or bigger than 100%. If it's written as a fraction, the big number's on top and the small number's on the bottom. However, if we have a reduction, the scale factor is going to be a number less than 1, or in other words, it's going to be 0 point something. Or it's going to be less than 100%, or as a fraction, we would have the small number on top and the big number on the bottom. Okay? So let's just go through now and just do a bunch of examples using those 3 basic formulas and kind of see where we're at. So it says a line is 3 centimeters long. If it is increased by a scale factor of 2.5, how long is it now? So notice it's going centimeters. So what we have here is we have original times plain old scale factor gives me new. So we go 3 times 2.5 equals, so my new line will be 7.5 centimeters long. Okay, so centimeters to centimeters is just plain old scale factor. Part B of the question, if the original line is changed by a scale factor of 40%, how long is it now? So again, we're still just going centimeters to centimeters. So my original line was 3 centimeters. Now, 40%, you need to either convert it to a fraction, so you can plug in 40 over 100, or you would convert it to a decimal, which would be 0.4. Either way, you have to use one of those in your formula. You're not allowed to just times 3 by 40%. Okay, you have to convert percent to a fraction or a decimal. So when you do that, 3 times 0.4, you get out 1.2. Now again, you can see here that my scale factor here was bigger than 1, so I ended up with an enlargement. Here my scale factor is less than 1, so I ended up with a reduction. So the answer should match what you're expecting to happen in terms of enlargements and reductions. So don't just blindly plug stuff in on your calculator. Actually think about the answer and think about what kind of number you expect it to be. In other words, do you expect it to be bigger or smaller than the original number? Because that will help you kind of decide if you have done it right. Okay, a tube is 20 centimeters long. A new tube is 16 centimeters long. what scale factor was used to reduce it. So again, we're just going from centimeters to centimeters. So we're just going to use our plain old original times scale factor equals new. So we're going to go 20 centimeters times by scale factor equals 16 centimeters. So if I'm trying to get scale factor by itself and I'm timesing right now by 20, then that means that each side has to be divided by 20. So my scale factor is, now again, centimeters just cross off, so you're just left with 16 over 20. So what we would want to do is reduce that down. So you can either write the answer as 4 over 5, so that would be writing it as a fraction. If you want to write it as a decimal, you'd write it as 0.8. If you want to write it as a percent, you would write it as 80%. Okay, so all three of those answers are acceptable. You don't have to give all three, you can just give any of them. Okay, the perimeter of a rectangle is changed from 30 inches to 75 inches. What linear scale factor was used for this change? So again, notice the units. It's plain old inches to plain old inches. So again, we have original times scale factor equals new. Now again, if you didn't recognize that, the question said linear scale factor. So linear scale factor just means plain old scale factor. So it went from 30 inches to 75 inches. So we can clearly see that this is going to be an enlargement, right? We went from 30 to 75. So we're expecting an answer here bigger than 1. Okay, so again, if I divide both sides by 30, so my scale factor is, so again, 75 divided by 30. If you reduce that fraction down, you get 5 over 2. So you can leave it like that as a fraction. Or if you want to write it as a decimal, you could write 2.5. Or if you want to write it as a percent, we write 250%. So again, because we went from 30 to 75, it's an enlargement. We were expecting a number bigger than 1. Or as a fraction, it's big over small. Or as a percent, it's a number bigger than 100%. Okay? Okay, the capacity of a container is 500 cubic centimeters. If the container is increased by a scale factor of 2.5, determine the new capacity. So again, you'll see the word capacity. You'll also see that the units are being cubed. So the formula that we have to use on this one is this. So again, because the units are cubed, we have to cube our scale factor. So the current one is 500 centimeters cubed. We're going to times it by our scale factor, cubed, and that will give me out our new capacity in centimeters cubed. Now again, the scale factor was given to me as a decimal, so I get to use it exactly as it's written. So I'm just going to punch this into my calculator, and I get out 7,812.5 cubic centimeters. Okay? So the surface area of a ball is 80 square centimeters. If the ball is made bigger by a scale factor of 180%, what is the new surface area of the ball? So again, look at your units or look at the words. So when you see centimeters squared, or if you see the words area or surface area, the formula we use is original times scale factor squared, because again, squared has to match the squared. So my original is 80. Now, the other problem with this is I gave it to you as 180%. So again, you can either plug into your formula 180 over 100 squared, or you can reduce it down to a decimal and write it as times by 1.8 squared. It doesn't matter, they'll both give you out the exact same answer. So if we go 80 times 1.8 squared, we get out 259.2. And again, we were expecting an answer bigger than 80 because it's an enlargement, and my units are centimeters squared. Okay? Okay, let's look at another couple of applications here. So we did talk about maps in class and how reading a scale of a map is actually a proportion. It's a scale factor. So a map has a scale factor of 1 centimeter to 80 kilometers. Okay, so you could write that as a fraction, as 1 centimeter to 80 kilometers, or you could write it as 1 centimeter to 80 kilometers. If two cities are 900 kilometers apart, how far would they be on the map? So the key with this is matching the units. So since I have kilometers on the bottom here, I would put 900 kilometers on the bottom here. And then what I'm looking for is the answer in centimeters. If you're going to do it this way, so this is option number 1. Option number 2 is to see that I have kilometers here. So that means I have to keep my other kilometers here, which means I'm looking for this. Now, when you have these types of questions, typically we end up with something that's called a proportion. A proportion is just when we have two fractions that are equal to each other, which is what we have. The way we solve every proportion is to cross multiply and divide. So I'm going to multiply, divide. So 1 times 900 divided by 80. Notice the math is the same here. 1 times 900 divided by 80. So it doesn't matter how you set it up as long as the units line up, and that is what's actually extremely important. Do not skip the step of writing in the units. Okay? So if you do, you might end up having the 900 in the wrong spot. So if you write the units in, so when we write the units in, you either want the units to line up bottom to bottom and top to top, or you want the units to line up left side looks the same, right side looks the same. It doesn't matter how you do it, whether you do it top to top and bottom to bottom, or left side to right side, as long as you have it lined up. Okay, so how far apart would those cities be on the map? 11.25 centimeters. Okay, next one. If a volume scale factor is 4.096, then what is the linear scale factor in the form A to B? So volume scale factor, so if you remember from volume, remember was usually centimeters cubed to centimeters cubed. That means that my formula was original times scale factor cubed gave me new. So this volume scale factor is represented as scale factor cubed equals 4.096. What I want is plain old scale factor. So we've done this algebra a few times in the course. How do you get rid of a cube? Well, you cube root. So using that button on your calculator, so if I go math number 4, I get 1.6. So this is it in decimal form. That is my linear scale factor. Now, you could write this as a fraction. So if you go math 1 on your calculator, you get out 8 over 5. So the question asked it in the form A, B. So you could either write it as 1.6 to 1, or you could write it as 8 to 5. They are both equally correct. Okay, so for scale drawings, okay, so last concept that we did, so it says the blueprint of W.R. Myers was made using a scale factor of 1 to 30. So what that means then, again, is that my scale factor as a fraction is 1/30th. Or in other words, the blueprint, the measurements on the blueprint are 1/30th of the actual measurements. Okay, so that's what that means, is that if we were to take our original measurements and times them by 1/30th, we would get out the new ones. Okay, or another way to think of it is I would have to take my blueprint measurements and times them by 30 to get back to my original measurements. So if my classroom measures 10 centimeters by 14 centimeters on the blueprint, how big is it in reality? So the new ones are the blueprint ones. What I'm looking for is my original. So if I use my formula here, so original times 1 over 30 is going to give me 10 centimeters. So I'm looking for the original measurement. So since I'm timesing by 1 over 30, I'm going to divide both sides by 1 over 30. So on your calculator, when you plug this in, make sure you have that fraction in brackets. You get out 300. Now put the units in. So 300 centimeters. And then if I did the other one, so original times 1 over 30 equals 14 centimeters. So again, my original length So 14 divided by 1 over 30, again in brackets, is 420 centimeters. So again, make sure you know your units. So it says give your answer in meters. So we know that 1 meter is 100 centimeters. So that means that my classroom would be 3 meters by 4.2 meters in reality. Very small classroom. Very, very small classroom. Okay, so that concludes our unit on proportional reasoning and scale factor. So try the questions that are attached in the assignment. If you have any problems, don't be afraid to ask.